Hey,
Hi everyone, let me see if we are live or not. So we are live on YouTube right now, and there are 40 people here. Wonderful, wonderful. Okay, good. Salil, you can start. You are on mute.
hey guys, welcome to today's session. I know there were some challenges and we people joined different links, but I hope we can get the session started today. Today's session is about synthetic data. And before we get started, just wanted to touch base. Welcome everyone. Good morning, good afternoon, good evening, wherever you're joining from, and welcome to an exciting journey into the future of AI. I'm Salil, your meetup organizer for UX for AI and Gen AI University. These are both members of our groups are joining us today. And UX for AI and Gen AI are communities that are at the forefront of bridging the gap between cutting-edge AI technology and practical applications. These groups have been instrumental in fostering a platform where enthusiasts, professionals, and those who are AI curious can gather and learn, share, grow in this dynamic field of AI. Now, without further ado, let me introduce you to the star of our event, Mr. Sandeep Giri. He's not just any other expert. He's a legend in the AI community. And with a rich 20-year background in transforming data into actionable insights, he has a very deep pedigree in AI and ML. Sandeep, for those who do not know, is a graduate of IIT. It is an MIT-like university out of India. He's worked on massive scale computing, starting with D.E. Shaw, where the Amazon founder Jeff Bezos used to work, in Moby, eventually at Amazon. He has been an AI leader and software engineer leading dynamic efforts across the planet. And the agenda for today. So our agenda for today is packed with insights. We have uh, uh, so a lot of people who are trying to develop Gen AI apps have ethical concerns, have concerns about finding or rather tackling head on the issues about data scarcity. There's privacy issues, there's other ethical issues about what type of data you're using to train or fine tune your model. And hopefully, Sandeep can offer us more insights into how we can move forward. After the session, we'll have like a small Q&A session with Sandeep, who has deep insights, working with the industry on delivering cutting edge applications and AI experiences. So grab a seat, get comfortable, and let's get ready to unlock new realms in AI with synthetic data. Just remember that by being here, you're eligible for a free certificate of participation and our way of saying thanks for joining this AI adventure. Now, let's embark on this transformative journey together and get started. Off to you, Sandeep.
Okay, okay. All right. Thank you, Salil, for a very good introduction. I'm really happy to have you as a co-panelist. Very, very glad to have you as part of the CloudxLab community. Wonderful, wonderful. And yeah, great. So I want to just start with, let me start sharing my screen, and that's about perfect. All right, can you see the screen? Let me also open the Q&A window on by the side. And yeah, great. All right, perfect. I'm super glad to have such a great audience right now. And yeah, so what we want to discuss today is how do you build the 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 AI or systems on top of AI or machine learning models. And when there is a data scarcity or data privacy problems. So one of the ideas that worked out well for many people is the synthetic data, right? When there is a data privacy issues, when there are so many ideas around data generation. I want to walk you through my own journey where we implemented at CloudxLab a couple of ideas into the synthetic data, and how would you in general utilize the synthetic data. Okay, all right. And all right, let me just get some of the things fixed. Let me see if the YouTube channel is up. Just give me a moment. I might pause the sharing for a moment and then go back to.
No problem. And for everyone who's joined in,
All right. And all right, let me just get some of the things fixed. Sorry, guys.
no worries.
There is a delay in the YouTube streaming, and the YouTube was streaming in my browser. Okay. All right.
And messages, can everyone message in the chat?
Yeah.
Awesome.
Okay. Yeah, I will also restrict the messages so that people should not start advertising. That commonly happens. Okay, let me go back to where we were. Perfect. Okay, and great. With me, there is one more person, Shubh, in the panelist. Shubh is one of our engineers from CloudxLab who works in the mostly the machine learning and AI, specifically the new ideas that I'm working on. My tech team from CloudxLab is basically instrumental in helping me. All right, let's start moving. And okay. This discussion is going to be of approximately 1 hour from now. We are already around 20 minutes late from the actual scheduled discussion. Okay, so we are going to, I'll just give you a brief about CloudxLab. At CloudxLab, the core vision is to upskill the engineers across the globe, specifically into deep tech, machine learning, and big data technologies, and make everyone employable and future ready. And at CloudxLab, it is basically the idea is that we have a playground. On the left-hand side, we have the content or the problem statement. On the right-hand side, we have the exercises, and you have to solve these exercises in the lab so that you can get the points and it checks your work in the real time. The next thing that is there is that you have the freedom to use the console and file system, and you can basically use any tool that is installed there. Almost every tool is already installed. The purpose of the lab was to give you a real experience, the way I had seen it in Amazon, I had seen it in my past companies, that there is a cloud-based environment given to engineers so that they can innovate and learn. Similarly, it gives a seaming experience. You don't have to download any software, or all the data sets are centralized, so you can utilize it. You can use it from any device, from anywhere. Further, you can learn better with your peers, and there are quite a few social, nudges available in that one, where one is you create your user profile, you can interact with each other, and so on. Next is the dedicated job portal, and where we keep on posting jobs. And then there is something called exam. At the end of the course, we conduct exams, and then whoever gets good scores above certain threshold, we connect them to the industry. And we have lots of courses on AI, machine learning, DevOps, MLOps, data engineering, data science. So feel free to explore. And there are lots of free content available, and the lab and most of the content that we have, the recorded content that we have, most of it is available as part of the subscription model. So you can just subscribe at a very low cost per monthly and start learning right away. And yes, so one of the things that is there is there is a huge dilemma of the data, right? If you have been following the news, New York Times sued the OpenAI for using their data, right? So there is always this fear that the data that is available, there are copyright laws and copyrighted, and the data that is not available, right? And for particular cases, there may be, you don't have the data, right? So there is a humongous trouble with the data as of today. Though there is internet, there is like all sorts of data available today, but because of various restrictions, so most of the models, or almost every model, learns from the data. In 1950s, when we were innovating the AI was more about human coded rules. We were writing rules and we were trying to solve it. Because of which the the AI did not work. And then the AI winter started. Because it is very clear, because intelligence can only build upon experience. Intelligence cannot be coded. If you're coding intelligence, it is basically a bunch of rules. And that is very, very, very clear when you think about how animals learn, how we learn. Nobody tells us that, to walk, you have to apply this much force, you have to take left foot first, right foot first. Nobody tells us that. We learn from experience, and that experience is essentially data. So just like living organisms, machine learning today is based on data. Looking at the data over and over, the AI infers the correlation, or the models are built around auto inferencing of the rules. And the GPT, or you can say Chat GPT, is a clear example that based on the data, you can actually build the real intelligence. Chat GPT is probably the most intelligent system human ever made in the history. And it is based on humongous data. The more data, the more complex pattern models can learn, better is their performance. Okay. If you're training a model on a smaller data versus the model on the larger data, the one that is trained on larger data is going to be better than the one that is on smaller data, right? And basically, the more the data, the better are the results. Okay. So here is on the right-hand side, you see something called a model size. Okay. Model size is saying that the size of the brain of the machine, okay, the number of neurons that are there, smaller, just like in the normal life, you have the smaller animals have not smaller, like the rudimentary animals have less smaller brain as compared to, say, animals like humans. Okay, so basically it is the brain size. And what people realize that as the model size increases, right? As model size increases, the the as model size increases, the loss, or you can say error rate, drops. So the bigger models are much more better. And for training bigger models, you need bigger data, right? You need bigger data. Now, it is very, so what I just established is more the data, bigger, you can train bigger model, and hence you can build better intelligence, right? So data, more the data, better it is. Okay. All right. Subodh and Robert, you have said you have a question to ask. Would you be able to type in the chat? Okay. Now, there's this aspect of data scarcity. So there is one form of data scarcity is there where you don't have the labeled data, right? And you basically have a lot of data missing in general, right? Specifically labels. And the other thing is that in the real world, that there are data acquisition challenges and data scarcity in the like sense that you will have to, you know, it's in general, the data acquisition is costly, time consuming, and resource intensive, right? Now, on top of that, there is this privacy paradox, right? Like if you have lots and lots of privacy rules built around, you will not have access to the data. And if you don't have access to the data, you don't have the intelligence. So the entire progress of AI will be throttled if 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 we do not expose or do not let any data to be available to the AI models. Now, collecting and using personal data raises concerns about unauthorized access, misuse, and potential discrimination. So, and because of which there is data privacy. So, on one hand, data privacy is important. On the other hand, if we basically are keeping every data as confidential and private, then we won't be having any data to train the models, right? So there has to be a line that to be drawn with respect to the privacy versus the availability of the data. Now, another problem that is there is the data bias. The data bias is, I mean, when you have, specifically volunteer bias, where you don't have the availability of instances or experiences from every circumstance. Like, for example, if your data is only available for a certain part of the world, right? If the data is mostly available on a certain part of the world, then that model is going to be biased towards that particular part of the world instead of everyone. So the model will become biased and will only give you the results with respect to only the data that was made available to it. Like, for example, if you have a million cases where cancer was not detected. Okay. And there was only, say, 100 cases out of let's say 1 million data set. 100 people had cancer and remaining people did not have cancer. Now you train a model on this. You train a model on this data, that look at this data and predict cancer. So this model will be biased towards not cancer cases, right? Because even if even if even if it's basically for every case it says that the person does not have cancer, what will happen? Its accuracy will still be very high because there are only 100 cases out of a million. Okay, which means there are 10,000 cases, 10,000 cases per the 10,000 negative cases which don't have cancer per one case of person who has cancer. So if this model just says that this everybody nobody has cancer, then this model is, what is the accuracy of this one? The accuracy of this one is 99.99%. Okay, a dumb model which does not have any knowledge and it just says that, looking at every case, it says that this patient has cancer, does not have cancer. Okay, the accuracy of this one will be 99.99%. Why? Because of the data bias. Okay, so the model will always give the discriminatory outputs if the input was biased data. There could be all kind of biases, right? Stereotypes, prejudice, and so on. So identifying and addressing bias through data cleaning and model evaluation is very crucial. And similarly, promoting diversity while you conduct the survey when you're doing the data collection and data generation to mitigate bias. Okay, so because it's a very common thing to you will hear many people saying, hey, we built this device which can give 99.99% of accuracy on cancer cases. But if you ask them that what kind of data that your model was trained on, then you'll realize that the model is actually dumb because there are only very few cases which had cancer. And therefore, even if the model is not doing anything, it is telling that every case is a cancer case, every case is okay case, does not have cancer. That means then also the model is perfect, is having like 99.9% accuracy, yeah, which is actually wrong. Okay, I hope I made sense. Essentially, data bias. Okay, data bias is very important characteristics and very important part to be managed when you're building the models. Now, using the synthetic data generation, you can mitigate biases at number of places. Now, this is where the synthetic data generation is pretty helpful. Okay, so artificially generated data mimics the statistical properties and characteristics of real world data. So the way synthetic data is generated is you look at the data that is existing and you basically pick similar data points, not same, similar data points with the same statistical properties in the real world. Okay, like similar distribution and so on. In every dimension, you basically look at the similar statistical properties of all the features. Okay, think of crafting the digital twin of real data points. Okay, so there is one more important use case of using the privacy part. So when, let's say, you have an organization, and your organization wants to use large language models, right? Large language models, say from OpenAI or Google Bard. Now your company says that we want to build the system, but we cannot expose our entire data. So what do you do? So what do you do in such scenario is that you do the synthesis of data. You have your data already. You synthesize new set of data based on what you have already, and you expose the synthesized data with OpenAI or Google Bard, and you work your way through it. Okay. So if your data has got this kind of a distribution, the synthetic data will also have similar kind of distribution. Okay, so the core idea of synthesizing data is that your output, the new data, should have the similar behavior. Okay, it could be from this synthetic data, could be from existing real world data set, or an entirely new data set can be created. It can be text data, it can be tabular data, it can be image, it can be video, it can be audio, etc. So essentially, you could take one photo and synthesize similar photos from that data. Okay, you can change all kinds of things from the background a little bit, and then start synthesizing the data. Okay, now imagine training AI with fake traffic data. Think of self-driving car. They need to learn how to navigate all kinds of traffic situations. So the way you train most of the models is you have this synthesized simulation, okay, on which you generate lots of data, and then you basically feed it to the models and let the model do the prediction. Okay, here's where synthetic data comes in. Imagine feeding the car's AI with computer-generated data that mimics real traffic conditions, including rush hour, bad weather, and even unusual events like car accidents. This way, the, the AI can learn all of this without actually being put into real traffic and without actually risking people's life. So essentially, most of the AI systems are trained in a lab for hours and hours and hours and hours. Only then they are put into production. Okay. And most of them are trained on synthetic data. All right. And before going ahead, I want to take a very important use case that we did at CloudxLab. Okay. Yeah. Yeah. So here is a very, very important use case that we did at CloudxLab. Okay. So we came up with this idea that we will build a tool that can convert a scanned exercises into our LMS. Okay, so given a photo, we had to identify which part of this photo contains MCQ or a fill in the blanks. Okay, and once we have identified that, we had to further identify which part is a question and which part is the fill in the blank, or which part is the multiple choice. Okay, once we had that, we would be able to automatically create exercises in our LMS, given a scanned copy of a book. Okay, books exercise. Now, this sounded great, right? And we needed some amount of good data so that we can retrain a model like YOLO. We took a model like YOLO, you only look once, which you can retrain, which we wanted to retrain on the questions, the images of scanned images of books containing questions. Now, here was the challenge. So we did not have resources or people to start tagging like drawing rectangles around every question, around every option, around every fill in the blanks and mark it. We did not have enough people who could do the labeling, and we wanted the labeling to be done. Okay, so data was missing. We did not have the data. What could we do? Okay, what could we do in these scenarios? So here was the very cool idea. What we did was we we generated the books, we generated the pages containing exercises. So we came up with, let's say, 100 templates, not 100 templates, I think, say 30 templates we came up with. 20, 30 templates were there, in which, and we came up with lots of text. Okay, and we took the text, feed it into these templates, and we generated lots of HTMLs. And these HTML were basically the pages of book. Now, we wanted to convert them into images and label them, right? Label as in mark which rectangles contains what. So what we did was we loaded them into Chrome, okay, using Selenium, took the screenshot, also measured the pixel from where to where is the question, from where to where is the answer. So we had the images and the coordinates of various places in the screen. So this way, we generated lots of data in every language, all kinds of format. We generated lots and lots of data with which we could train our models. Okay, and it turned out that we improved the performance drastically by creating synthetic data. And this is a real use case that we have done at CloudxLab earlier, and we probably would be launching somewhere in future this particular product. All right, going back to where we were.
There was a quick question. Rajat asks, kindly explain in terms of text data how synthetic data is generated. You might be coming to that already. So.
Yeah. Okay. 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 Now, all right, we already talked about it. Basically, the way we generate the data is, let's say, we have something confidential, let's say the phone number, right? And the models can look at all the numbers in this table, okay, and understand the format of the phone number based on what they have seen, and essentially generate new phone numbers based on what they have learned from the whole column. Similarly, the models can learn from the column type and what is there in the column, and then start generating these fake data, okay, the fake data. And essentially, this way you are going to save the confidentiality of an individual. And if you, let's say, go for age also, it will basically, do all sorts of, all sorts of generation of the age as well. Okay, so given this set of data set, the AI will be able to generate a larger set of the data set on the similar lines. Okay, And of course, it might look like that if, let's say, we took this data and kind of zoomed it out, and then we tried to fit a model on it, we would most likely be overfitting this sample set. Okay. Next is that the benefits of synthetic data is that we would be able to overcome the privacy concerns, and so that nobody can basically figure out the actual name of the people. Like in organization, a number of times what happens is, let's say take a case of Amazon wants to give the recommendation data to the employees. Now if they completely delete all the, I mean, they want to give the data to employees, as in those engineers who are working on recommendation engine. Now one is that you delete completely all the features that contain confidential information. That would not give engineers the it will completely remove the meaning of the data. So in such scenarios, you kind of obfuscate or change the names of people and anonymize the data. Okay. The AI models can also make, if the smaller model has only few things and did not have other things, it would be better if we have a data which is derived from the basic one. So when you have a larger data set, the chance of bias comes down. Okay. Businesses can tailor synthetic data to specific requirements, and creating synthetic data is much more budget friendly, as I explained. And it is better to go for production. Like if we waited for humans, I mean, the people we let's say we hired many people to label and mark rectangles on a page, it could have taken a lot of time, right? So the techniques and the innovative techniques that are there with respect to synthetic data generation are marvelous as of today. Okay. So the model accuracy has been demonstrated that the model accuracy of a model trained on synthetic data versus the model's accuracy, the same model's accuracy on real world data is very similar. Okay, is very similar. So it has been proven over the data set that if a model is trained on synthetic data and when it is put into production, its performance is comparable. Now, how is the synthetic data generated? There are several methods to generate synthetic data. The first one is using generative adversarial networks. And I'll come back to them one by one. Okay. So those of you who do not know what exactly is generative adversarial networks. Generative adversarial networks are two neural networks or two brain and competing with each other. These two brains, one of them acts like a counterfeit designer, and the other one acts like a police or somebody who catches the counterfeit guy. And both of them compete with each other. While the pirate is pirating, let's call it pirate and let's call it police. The pirate is pirating new things, new data, generating new data, and this police is trying to catch it. So both of them are learning simultaneously. So generative adversarial networks are basically two brains learning together. One is trying to catch the other one, and other one is trying to build such a nice real looking system so that the police can't catch. And in this competition, both of them become really good. The generator or the pirate also becomes really good at generating, and the police also becomes really good at catching. And as the time passes, both of them improve together. So at the end of it, you have one model which can generate fake things, And you have another model which can catch and detect whether something is fake or not. Okay, so you can see there are quite a few very good works. One of them is this person does not exist. Okay, so this is generated by generative adversarial network, and it is essentially a fake person. It does not exist. Okay, so essentially you can create more and more features and faces. Okay, and to catch this, you will have to have the second part of the generative adversarial network, which can catch the first model to if it's generating or not. I mean, the second part of the model can be used to detect if it's a fake face or not. Okay, so there are quite a few use cases. I mean, quite a few systems that have been designed on top of GANs. And one of them is the synthetic data generation. GANs can be used not only for generating faces, but also for tabular data and the words and so on. Okay, the generative AI that you see today is basically a derivative of what generative adversarial networks came up with. So it's great for generating complex data such as images, audio, and video. It can capture intricate relationships and patterns within the data. Weakness is that since it's a neural network, it requires extensive training and careful tuning on network, a lot of parameters. It can be computationally expensive. Okay. Now, the second strategy is to do the statistical modeling. Okay. Statistical modeling is like if you have most of the generated data between, okay, so let's say you are a teacher, and you have to give the grades to people. Okay. Or you have to, let's say you are, if you must have done physics experiments, right, in your college. Okay, you must have done the physics experiments. And let's say your physics experiment was not successful. Okay, what would you do? You would look at the neighbor's notebook and generate your data on the similar line, right? And of course, when you are generating this data by hand, you don't want to do something very stupid. So you look at how is this distribution. So you see that, okay, most of the values are between 1.1, 1.2, 1.3, 1.4. And there are very rare values above 1.4. So you will generate some data. Most of your data points will be between this and this. And some of the data points will be away from it, just to make it look real. Okay. And so this is basically trying to understand the distribution of the data and then faking it. Okay. That's exactly what is statistical modeling about, right? And you all have done it. I know for sure that you at some point of time have faked the submissions, right? So basically, the statistical modeling is essentially looking at the data distribution and then coming up with new data. All right. So it's efficient and relatively simple to implement, can be effective for generating simple data types like numeric data and text. Weaknesses, it's only limited to the text, limited to the numbers and other things, not for all kinds of complex data formats. Okay. This approach leverages human expertise and domain knowledge to define explicit rules and guidelines for generating new data. These rules could involve relationships between different data points, constraints on specific values, and so on. Now, this is important. So, this third technique that we're discussing now is called rule-based methods. Okay. Rule-based methods is basically like what we did for generating the quiz data is the rule-based method. It is based on the human knowledge that how to generate HTML, how to generate this, how to generate that. Okay. So basically, the simulation methods are also part of the rule-based methods. Okay. So they can be very effective to generate the data, but there are weaknesses that there's a manual effort and the human knowledge is needed for doing it. Okay. I hope I'm making sense so far. Now, harness the power. Next is the deep learning based techniques, such as autoencoders and variational autoencoders. These are basically again, generative AI models. They take the, they look at the older data, and let's say, look at the older data and learn to paint the same picture. Okay. So these models are like artists who are learning to just clone what is there. Okay. And when they clone and clone and clone millions of such models, they generate something called encoding in the brain, right? So, and you basically throttle their brain so that they don't memorize everything, right? So you basically have something called a throttle in the neural network, and using that part, we basically make the model, we constrain the model not to memorize the input and generate the same input. So it's the same thing as is. Instead, we make it look at the picture, close your eyes, now draw the painting. Okay. So and whatever you are memorizing is limited. So you basically make a model, make a machine, look at the photo, and you give the machine a smaller memory to memorize it. Okay. Now, machine will work hard to save this entire thing into a smaller memory and then recall the rest of it using that smaller memory. Okay. This is called autoencoder. Autoencoder is a technique that is used widely to teach machines to be creative. Okay. So and you don't have like training data. You show it lots and lots of photo, make it memorize, ask it to paint the same thing. After, making it, maybe make it store this thing into a small dimension, and then you make it paint the same picture, right? Now, this way, you have constrained the memory, you have forced it to learn about the input data so that it can compress it into smaller memory and then generate the actual photo from it. Now, this technique is called the autoencoders, and variational autoencoders are a little slight bit of different aspect of it. Now, what happens is when this machine is again and again trying to draw the picture or create the same thing that it has seen or listened to, it comes up with an internal brain that has learned about this new thing, and therefore it the coding that it had generated, now you can randomly choose the coding and it will generate new things. Okay. You randomly choose the coding and it will generate new things, new objects. So autoencoders, once they learn how to create the entire picture from this small memory, they become creative. They are able to create new things. So these are some of the techniques used in autoencoders in the deep neural networks in order to be, making creative neural networks or generative neural networks. And using these techniques, you can create new data. All right. All right. So deep learning based techniques, they're basically pretty creative. Like, for example, one in my course, when we are teaching the autoencoders and other things, at one point we teach it to draw clothes. look at the shirt, memorize it, put it in a smaller memory, and then look at this memory and now paint the picture. It's not allowed to see the actual picture now. It's only allowed to see this small memory. Now, when we did this, it made two kind of brains. It basically prepared two kind of brain. One brain which takes the input photo, converts it into smaller numbers that we call encoder. This part we call encoder, and second part is called decoder. Decoder takes this small set of numbers and convert that into a entire picture. Now we got encoder decoder, two brains. One is encoding the picture into some numbers, and the other taking these numbers and creating a picture back. Now, using this technique, we can create new instances by the decoder part. Just give it some random number, it will create new instance of person. And in one of my courses, we basically learn how do we create new clothes. Okay, so we train a model to paint the picture of the clothes and using this encoder decoder technique, and then give it random numbers and it starts creating new clothes. Okay, and at the same time we encode, let's say, shirt, pant, both together, and let it generate those numbers, and then merge both the numbers, take the average of this, and then give it to decoder. It actually generates the onesie, right? It combines the shirt and pant together. And it's very funny. And you can actually just combine all the three things together and it'll just give you some bunch of numbers that you can average it out. And that's the magic of it. So you can actually generate synthetic data using the deep neural network techniques. Okay. All right. So there are disadvantages of the synthetic data. The reliability of the data, the quantity of synthetic data depends on unbiased input and the model used for generation. And there could be, of course, when we are synthesizing data, of course, it will not be exactly like real world. There will be biases, and it will amplify the biases also in the actual data, right? Synthetic data can't perfectly replicate real-world outliers, which might be crucial data points. Now, expertise in time and effort is required in order to generate the synthetic data also. Okay, and this part we have already discussed. Okay, so yeah, here is a very important slide. I think you can take the screenshot of this one. So there are quite a few tools that people use, okay? Out of which, so far, we have been using Gradle, specifically for data generation. And there are other tools as well. Datamize, Mostly.ai, Synthesized, Hazy, Sogeti, Gradle, Cvadia, Rendered, OneView, MDClone, out of which we have so far used this one, and I've not tried the other ones yet. Okay, so these are various data generation tools. With that, yeah. Thank you, everyone. Keep the questions coming. It's open for questions now. All right. Feel free to ask any question.
We have a question here. Smriti asks, do autoencoders help with creating synthetic text data as well?
Good question. Good question. So, kind of yes. The autoencoder, right? The thing that you see as part of the Chat GPT. So you can think of Chat GPT like this, right? I'll just try to show you. Okay. So I mean the people have not yet. People must have tried with that autoencoder earlier, but similar model with respect to ChatGPT is actually pretty powerful and useful. What people do is they take the text, right? Feed it to a neural network. Feed it to a neural network. Okay, feed it to a neural network. We call that encoder. Okay. And then basically it generates the encoding here. And here there is a neural network that is a decoder. And you basically have the output. Okay, I'll explain to you. Okay, now here when it generates, it represents it as bunch of numbers. We call that codings. Okay, it generates codings, and codings are nothing but like an array of numbers. It's a array or list of numbers. So essentially, you feed the text, it can takes neural network takes it, generates the codings, and tries to output it. What has worked out well, instead of trying to replicate the same text, it tries to replicate the next word. And this is exactly what ChatGPT model is. The embedding that you see in OpenAI, you can actually use embedding, right? Instead of encoding, they call it embedding. Okay, so you can use OpenAI's embeddings, and using the embedding, similar embeddings, you can generate different data. Okay, you can generate different data, and this we have done a couple of times. That let's say we have group of text and we have group of text whose embedding we have computed, so we take the average of all the embeddings, and then we can ask the second decoder neural network to give us the text, and this is quite popular and useful. Okay, all right, I hope this makes sense to you. So yes, autoencoders can be used for the data generation, for the text generation, but mostly people use the ChatGPT or the LLM, large language model kind of things so far. All right.
There's another question. Sri asks, do autoencoders have reduced hallucination rates compared to LLMs?
Good question. Good question. The autoencoders have autoencoders have less hallucination rates as compared to this? I don't think so. First, I don't have much of data on this, but I would love to do this research sometime, that the will autoencoders have less of hallucination, but I don't think so, because autoencoders also hallucinate, and the way we want autoencoders to hallucinate more, because they need to be creative. Okay, so I can't answer this right now exactly, but I feel that autoencoders will also be hallucinating similarly to large language models. Okay. Okay. All right.
I wanted to, add to what you just mentioned, that people are taking the fact that these LLMs hallucinate, and they are looking at it as a bug more than a feature, where it should be looked at as a feature more than a bug.
Yeah.
So I would love to hear your thoughts on that topic.
No, your interpretation is correct, right? If you have, let's say what we did at one point of time, that we did not want it to hallucinate. So what we did was we took our data, and at that point of time, OpenAI was supporting retraining the model. So we retrained the model on our data, and it started becoming pretty dumb. Okay, it kept on just saying the same thing over and over. So the more we tried to cage it, the more we tried to make it constrained and so on, the lesser intelligent it became. Okay. The and I think being able to hallucinate is also, you can call it, it's creative. Okay. All right. So creativity and hallucinations are similar words in this context. Yeah.
Yeah, and I think, we as an industry need to move away from this idea. Again, we are anthropomorphizing AI by calling it a hallucination, but it is a feature, not a bug, because that is what lets it
Yeah.
create the magic that we think are LLMs.
Yeah. But at the same time, right, we use LLMs for lots of cases, right? For example, a bigger use case is to be able to generate SQL and execute it. Nowadays, the new generational tools that are going to come, the new generational tools that are going to come, are going to be much more. Most of these SQL analytics tool. Earlier, there used to be Tableau and other tools that you must have heard of. There were these tools which were used by people to generate analytics. Now, the new generational analytics tool will be language or voice based. Okay, and they'll basically, you'll ask a question, give me the most valuable customers of last 3 months. Okay, and it'll basically show you the charts and show you the data then and there, right? And how it's done is, you basically ask LLM that, here is my database tables, here are my database tables. Can you generate the SQL query? And once you have SQL query, you go to the database and query the database. Now, if in such case, if LLM hallucinated, it came up with new tables, it guessed some new tables and so on, that could become a big security threat. So this creativity could become a security threat at some point. So what do you do in such cases is that, like right now, one of my open source projects that is going on is that we are trying to build a SQL security framework, which will be concrete in the sense that it'll take the SQL, compile it, interpret it, and then translate it to the new model. So this is what we are trying to do right now. So there is, in some use cases, the hallucination could be fatal, but you have to handle that part. Also, in basically some of the use cases, their hallucination could not be tolerated, in the sense that if let's say somebody tricks the model to generate the query which deletes the tables, that could be dangerous. Okay, so one is hallucination in underneath in the model. It's a good thing actually that it is able to being creative. Second thing is um, second thing is you know your customer or your user tricking it to do something. Okay, so anyway, I think in certain circumstances hallucination could be disastrous, but there are techniques to kind of solve those things.
No, I completely agree. I think, there are spaces where this creativity is a plus, but there are cases like, if, let's say, you're trying to build a healthcare or mental health bot, excuse me, there could be use cases like that where you cannot afford that hallucination, where you cannot afford those mistakes. So, and like you correctly, we're going towards transitioning towards this. There are advanced RAG techniques, so that is retrieval augmented generation techniques, which can then help ground the LLM into, the ground truth or the ground reality that we are trying to purport. So again, I think that would need another entire its own session. So
Yeah.
yeah, I'll open the floor to everyone and anyone who has any questions.
Yeah. Well, I think we should organize the talk on the you know mm, the RAG part. Okay, how do you build a RAG? And we would be doing that soon. So the code that we have built for doing the RAG is retrieval augmented generation, meaning how do you build your own chatbot on your own data. So we will be making that available, the entire code, to everyone, and so that everybody can build the chat system, the Q&A system for their own organization, and in minutes. And that's what we'll be making it open to everyone soon. And we'll also conduct a talk on both parts. One is the RAG, other is the SQL security. Okay.
Yeah, that sounds great. I think, do we have any questions?
Yeah, there are
Folks?
quite a few questions. Yeah, let's pick one
Okay.
up.
So the first one, Sri says, is it necessary for encoders to have creative capabilities for synthetic data models? And is there a metric to evaluate synthetic generated data?
Right. So essentially, encoders naturally come up with the encoded numbers, and if they understand the numbers well, they should be able to create new things if we just tweak these numbers a little bit. Okay, so it becomes very simple that autoencoders are creative naturally, right? Encoder part is not creative. Encoder part encodes it. It's the decoder part that's creative. Okay, is the decoder part, because encoder converts any input to in numbers. But when we are being generative, when we are creating things, we take the decoder part and just feed random noise to it and see what happens. Okay, so that's called the I mean, of course, the naturally autoencoders are, or decoder parts are pretty, if trained well, they are creative. And is there a metric to evaluate synthetic generated data? Good question. Good question. The probably for number cases there is a clear metrics. For the other non-numeric data, it's difficult to measure. And if we are very concerned about the measuring part, we usually go with the generative adversarial networks models. Okay, very good questions. Next one. Sorry.
Yes. So next, Shivansu is dropping some knowledge. I think Shivansu, when he had used GANs produced sharp images, but only in fairly small resolutions and somewhat limited variation. Training continues to be training continues to be unstable despite recent progress. Generating high resolution image has been difficult. And Shivansu also adds more context there. To overcome this, he suggests growing both the generator and discriminator progressively, which might lead to being more effective and efficient.
Yeah. Thank you, Shivan. So that's quite a good input. So yes, usually there is a term called mode collapse. Mode collapse when you have in generative models, specifically the generative adversarial networks. What happens is that when we are saying that there is a police and a thief, so if both of them decide to be chill, right? So they will stop improving each other, and that's where the I'm not improving because police is not good. Police is not improving because the creator is not clever enough. So essentially, that phenomena is called mode collapse, and that's what is that it is unstable. That mode collapse makes the entire training to be unstable, and that's what Shivansu says, that growing both generator and discriminator progressively is something very important. Like first you train these to a certain level, and then you keep on moving up the level, and that way the training is becomes better and better. So yes, so thank you, Shivansu. That's
right. So just to summarize, essentially, let's say you're trying to generate an image, you would try to create a model that is creating smaller few pixel, like, let's say 100 by 100 images, and eventually progressively grow that model to be able to do like a 1080p kind of image. Is that fair?
Yeah, yeah.
Thank you.
Yeah. And also you can also have like the first you train the model on more real data and so on. And then, I mean, you can increase the sample size on the decoder side in the generative networks, the adversary. So there are ways in which you can basically increase the volunteer data more. Okay. I think that is a bit advanced part, but you covered it well. So that's you can think of it like we are progressively increasing more complex outcomes.
Makes sense. So next, Aditya asks, are these data generation tools built with generative adversarial networks or GANs?
Yeah. So there are many techniques. So we talked about multiple techniques. First one was rule-based, or you can say rule-based slash simulations. Okay, rule-based slash simulations are the same bucket. The second one is the statistics-based, where we basically look at the distribution, and in the same distribution parameter we generate. The third one is the autoencoder, and fourth one is the GANs. Okay, and LLMs also fall in the same bucket.
Makes
Okay.
sense. Aditya, I hope that answers your question. Next, Robert asks, what is the future of data science given new development in AI automation of tasks, specifically, I suppose, data tasks, like data analyst roles?
You want to take a first cut, or should I go ahead?
No, I think go ahead first, and I will add any thing I feel. Thank you.
Perfect. Yes, Robert. So I think that's true in almost everything. Okay. I would say that the data science jobs have become suddenly much more interesting. Okay. Now, much more interesting from two perspectives. Number one, all AI models need data, so data cleaning, data arrange, all of that have become hotter and hotter. That's first thing. Second thing is, most of the work that was done by people earlier, you can essentially ask the LLMs or ChatGPT Bard to generate code for you. Now, basically, it has suddenly become much more interesting that the labor work, which you had to type it all the way, is now suddenly generated by them. So you can copy paste, fix the errors, and further optimize it. Think about the problem more than the code. Earlier, your most of life was gone in getting the code typed. Okay, so programming or technology suddenly have a typewriter. Okay, and right, basically this is something that is extremely extremely great moment, right? I remember once I was in Hyderabad, and one of my friend who was designing a newer programming language, and so he came to meet, and he did not shake hand with me. I said, what happened? He said he has got cramps in his both hands. Okay. Okay. I said, why? What happened? He had been busy entire week just coding up the compiler, and because of which he has got these cramps in the hands. And then I asked him, like, how are you managing? Then that company has got me a typewriter who types the code while I speak. And right, and he says that it is more painful right now to get somebody to type the code for me, because right. So that kind of the typing part of the coding has been minimized thanks to the new development. Okay, so I feel that now is all the more reason to be doing data science and AI, because data science is an integral part of AI, or AI is an integral part of data science. So, I mean, if you think about it, the most of the work in OpenAI, ChatGPT, LLM is more about arranging the data, making sure cleaning the data, and training the model. Training the model is it requires hardware, but the most of the engineers' work is actually just cleaning up the data. Okay, so yeah, so data science is going to be even more important.
Yeah, I mean, I think Robert's question, what I see here is like, what is the future of data science given the new developments in AI automation of tasks? It to me, it speaks of the insecurity that we as humans have of being displaced by the new changes in technology. And I think, like you correctly pointed out, it is just going to move humans further up the chain of the type of work that they were able to do. So earlier, when you had data analysts or data scientists on your team, they were doing grunt work. They were almost like, you have a natural language question, they have to write code to look that up. Now you can do that yourself, and you can redeploy those same resources to do something more intelligent, something of a higher value, a higher business value for the enterprise or for your users, right? So I think we should definitely be, like you correctly pointed out, data science and AI go together. And those who have understood the basics will just move up the value chain and be able to do more things and unlock more potentials.
Right.
So the next question is, Smriti asks, would you advise using synthetic data for fake news detection? I'm short of data.
So I think, yeah, I think in case of the fake news, right? The thing is, good question, good question, good question. Uh-huh. So the problem is that there are two parts to the data. One is the actual data, and other is the label, right? I'm just trying to think aloud that for fake news detection, right, would having the data, synthetic data, suffice, or would we want to have the real data? In my opinion, specifically in such cases where you are building this kind of model, which is really, really hard because there's a very thin line to detect between fake news and real news. I think you would require human labeled data on fake news and real news, right? At the same time, my recommendation would be to see if you can crawl this data from various sources. Look at look at some of the places where fake news has been posted. And I think here, in case of fake news detection, the most important part would be to come up with ways to label the data. And of course, the features, right? One feature of the news is the news itself. Second feature of the news is the formatting of the news. The third is like which channel is it posted on, and so on and so forth. So I think it's a fairly hard problem where you need to come up with the features of the news. You have to come up with the labels of the news, and you have to do that. And at the same time you would not require too much of data right now. What you can do is you can convert each of the news into certain encoding or embeddings. And once you have, let's say, 100 or 200 records, or maybe, let's say, depending on the columns as well, so you have, say, 500 records, you can do a model fitting with a smaller model. Okay, so I would say that Reduce, number one is gather real data as much as you can in this particular case, in your case. Number two, translate the data into good set of features. And if the features are too many and your number of instances that you have collected are too few, try reducing the dimensions by projecting it onto a lower dimension space using unsupervised learning techniques. And then once you have that, then you will be able to come up with a model like SVM or linear regression or decision trees or random forest to segregate the fake news with the real. But yeah, I think you can get in touch with me. I'm available on the LinkedIn, so if you want more details on the approach. Okay.
Yeah, so Smriti, you can get in touch with Sandeep. I hope that answers your question. Just on the philosophical side of it, as like a regular human, like I think Sandeep gave a very great answer from an AI perspective, as a technology's perspective. Just like the philosophical perspective is how can a model define, or rather how can fake data help you figure out fake news in reality, would be a more nuanced question to answer. And like Sandeep suggested, the features or the parameters that you would choose in trying to build such a model would have to be very interconnected and involved effort from different parts of societies to make sure that it has reduction in bias, doesn't perpetuate the same challenges that we've had in the current media state. So moving on to the next question, Aditya asks, can we use News API to get the latest news and then use a GAN decoder to come up with the same data, but we will grab the data which are in previous training of encoder to get certain fake news as they are different? I think Aditya is offering another perspective on how this can be achieved.
So let me read it again. So can we use News API to get the latest news? Okay. And then use GAN decoder to come up with same data, but we grab the data which are in previous trainings of encoder to get certain fake news. I would still say that, we have to, extract those, we have to figure out how do you really detect a fake news? Okay. And I think generating synthetic data may generate a news that is actually, there's no difference between fake and real. So I mean, it would be impossible, but we may be able to build a model to differentiate the two, but that model will be very difficult. Okay. So I think I would still say that if I have to build the fake news, I'll actually gather the data and label them. Okay. Because there will be what we have to do is we have to figure out what are those characteristics. And like maybe the fake news have the characteristics like spelling mistakes. Okay. Or emphasis on something enormously. So best way would be that gather both the data, convert that into embeddings, train a model to separate the two, and model could be anything and so on. If the features are too many and the instances are too few, try reducing dimensions. Okay. All right. I would still, honestly, I'll focus on specifically this particular fake news case. Yeah.
So Rajat says he's building a SaaS recommendation system that looks at monolith applications, tech stack, and other infrastructure dependencies, and recommends the public cloud SaaS alternatives. So I think what he's suggesting is look at monolithic tech stacks and infrastructure dependencies, and come up with a SaaS recommendation system that uses free open source SaaS alternatives. He doesn't have any historical data for supervised ML. How do I create synthetic data in this case?
I think you can use the ChatGPT or Bard or any other LLM to achieve similar thing. It will be a matter of creating and augmenting a good prompt. Okay, so that would be my take on that. And but I would love to discuss it in more detail. This is something that can't be answered in a couple of minutes. This requires much more diligence. All right.
Awesome. So I think we have completed all the questions. Last words, Sandeep.
I'm thankful to everyone, and thank you Salil, and thank you Shub, and thanks to my team, and wonderful set of questions. I really appreciate the amount of the questions. And there was one person who say you did not answer my question. I did not see your question. Okay. A question from Brello is, are there any specific regulations or standards concerning the use of synthetic data to protect privacy? Okay, let me see. Yeah, sorry. Okay. Yeah, so basically, right now there's no standard as such, but people use Sigretel and these tools. I want to, yeah, before we um, right, and a question from a point from Shivanshu is that I, I, I think not sure, but bootstrap aggregation will be able to take better decision in, yeah, uh, yeah, but I think it is a matter of preparing the data set more. Okay, thank you so much, Shivanshu. And yeah, I wanted to just to give you an overview. So we are starting off with this PG certificate course where we deep dive into everything, including reinforcement learning. And we basically also do the deep dive on the entire ChatGPT architectures and large language models, variational encoders, natural language processing, and computer vision. So I invite all of you to apply for the course. And this course is quite exhaustive course. It is one of the most in-depth courses on the uh, planet, probably in machine learning. This is a certificate course. It's an equivalent from the perspective of the content. This is equivalent of a master's degree into the AI. It includes each and everything from starting from Linux, Python, and everything up to building your own models. Okay. All right. All right. So thank you, everyone. There is one question from Ren. I'll answer that. We want to build a model to analyze chord progressions and vocal melodies of songs. Okay. Okay. Can you explain how the process would go? Okay. I want you guys to take a look at there are this what do you call this? Mm, Google Magento. Okay. Google Magento is mostly open source initiative. Most of the work they're doing, uh, Google Magento. Google, okay. Not this. Magenta, not Magento. Okay. So you should take a look at the open source research project that would actually help you understand the art specifically with respect to the deep learning. And right, there would be more and more involvement of, say, things like doing the Fourier transformation of the music in order to do various analysis. Okay. I mean, there are lots of libraries available in Python. You can use them to convert the input audio into the frequencies, and then you can apply the neural networks and other things to achieve various kinds of things. Okay. A question is that can we use synthetic process? Yes, very good question. I'll share one small interesting idea that I did for my kid. So I was struggling with getting the music for my son, um, because he was learning to drum, and we needed the songs which do not have drums. Okay, so now I wanted to build a model where you have a you have a song and you feed it to the model, and model will remove the drums from it. Okay. So now I needed a data set, drum, song with the drum, song without the drum, same song without the drums. Now, how would I generate such kind of data set, right? I thought over it. Then what I did was I found like lots of songs on YouTube. Okay, lots of songs on YouTube which did not have drums, drumless. They call it drumless, right? And then I got random drums. Okay, then I just downloaded say hundreds of drums melodies, and then I started merging these, let's say, drumless with the drums and got the new song. And then another drums got the new. So I kept on synthetically generating this data. And then now I trained my model using this data, and that worked. Okay. Of course, it did not work on a scale because you are taking too much time to train and it was too slow. But at least the synthetic data generation was quite useful in this case. All right. I hope that's what uh, probably you have to cleverly figure out how can you get the data generated for your use case.
That is a fascinating use case.
Okay.
So Camille asks, he has a question. Can we gauge how can we fail a chatbot where it goes unanswered?
Just give me a moment. So yeah, Rain, you can reach out to me on LinkedIn, or you can just drop me an email at research@CloudxLab, and we can talk. Okay. All right. But this is, I would have to understand exactly what you are trying to do and if I can add value in that. Okay. But yeah, in simple way, just search for Sandeep Giri on LinkedIn and then you'll find. Okay.
Awesome. I think we'll take the last question. Can decoders auto detect hallucinations? If so, how and to what extent?
Good question. Good question. Huh. Yes and yes and no. If the hallucinations are very good, then decoders won't be. If decoders are very good and the hallucinations are okay, then you can. So the answer is extremely subjective. Okay. I mean, that answer is only, the entire generative adversarial network can answer that question. Okay. And it's a hard question to answer. All right.
Awesome. So I guess this is a close to the session. And with that, AI enthusiasts and visionaries, we've come to the end of another illuminating session by Sandeep on crafting the next generation of AI models using synthetic data. And as we close this chapter of our journey, I just wanted to extend my heartfelt thank you to everyone who has joined us today. Also wanted to appreciate all the engagement and curiosity you brought to the table. It's what fuels these discussions and drives, amazing results forward. Special thanks to Sandeep, our insightful and incredible speaker. He has always been an approachable guide through very complex topics. Sandeep, your expertise and passion for AI have certainly shed a light on how we can turn data into a more powerful tool for innovation, for business innovation, for personal innovation, and beyond. I also want to acknowledge the efforts of UX for AI San Francisco and Gen AI University Vancouver for bringing more people on board. These groups are more than just communities, and they are incubators for ideas and platforms where AI dreams can be transformed into reality. As we part ways, do not forget to claim your certificate of participation. Shubh has dropped the link in the description. And thanks again to Shubh and the CloudX team for your commitment to helping people learn and grow in the field of AI. And I remember, a reminder to us all is that this is just the beginning. The future has more things in store, and we just have to keep creating and keep pushing the boundaries of what's possible. So thank you once again for joining us, and remember that future is in our hands. Let's shape it together.
Yeah. Thank you, everyone. Have a good day.